Hey guys, I'm going to make a quick video going over chapters 2 and 3. I noticed that only one person was able to come to the Zoom yesterday, so I'm going to make a quick recap before your test. Alright, so when you look at your periodic table, this is what you will see that represents the element. So this is the element symbol. That's going to be like an abbreviation of the element name. So then we have the mass number, which is going to be this number at the top, which is your protons and neutrons together. And then the atomic number will represent your number of protons, which is at the bottom. So isotopes are elements with the same number of protons and neutrons. So for example, if your mass number is 4 and your atomic number is 2, which means you have 2 protons, which means you will also have 2 neutrons. So you have the same number of protons and neutrons. So this represents electrons and potential energy. So this is the electron shells. So as the electron goes out into farther shells, it gains potential energy. So it has a greater potential energy here than it does here. Okay. Okay. So the compounds are between different elements. So it's not, a compound isn't 2 of the same element. It is a combination of different elements. So here we're going to talk about polar. When it's polar, it is sharing one. It is unequal, so it's sharing unequally. It's sharing the electrons unequally. So the oxygen. Let me show you the periodic table. So oxygen is here at 8. Oxygen wants to be 10 because they want to be like these. Oxygen wants to be 10. So from the hydrogen for H2O for water, from the hydrogen, it has 1. And really it wants to be 1 because it's over here. Really it wants to be 1. So oxygen is going to take 2. That's why it needs 2. So oxygen is going to take 1 from each hydrogen. Because oxygen wants to be 10. They want to be 1. They're sharing. So this has the 1. This is taking that one, 10, 1, 1. So that's unequal, which makes it polar. All right. So non-polar, they do share equally. So once again, the hydrogens only want 1. So since you have them 2 together, it's going to be 1 and 1. They're sharing them 1 and 1. All right. Ionic bonds work because of the attraction between positive and negative. Okay. Hydrogen bonds are covalent bonds. They are made from hydrogen and another element. So that'll make it easier for you to know. Like that's a hydrogen bond because it's hydrogen and something else. All right. So once again, the more positive and the more negative. So we have water and ammonia, and the hydrogen is attracted to the nitrogen. So because it's more positive, more negative. All right. Covalent bonds share 1 pair of electrons. So that's, yeah. Water is connected by hydrogen bonds. So these are waters, H2O, H2O, H2O. And that's how they will look because negative positives, positive attracted to negative, and it goes on like that. Okay? And it's more positive, more negative. More positive, more negative. All right, heat. Sorry, I can't really see it. Okay, heat is energy given off from motion, which is kinetic energy. So H bonds break, that absorbs heat. So when hydrogen bonds break, heat is absorbed. I think about it like if you break something like a vacuum, if you break the side of the spaceship, all of the stuff is sucked. So that's what I think about it as. It's absorbed out into space, right? All the stuff is absorbed out into space. So that's what I think about that. Then when H bonds form, it's released. Okay? So it's the opposite. When they form, it's released. Okay, so let's talk about lemonade. So when you're making lemonade, what are you putting into the lemonade? You're putting lemon and sugar. So that's going to be our solute. That's what the smaller amount of stuff that you're putting into the bigger amount of stuff. And the bigger amount of stuff is going to be the water, which is a solvent. So then that makes our total solution lemonade. So you put the lemon, the sugar, and the water together to make the solution. The solute plus the solvent is the solution, right? So the solvent is more. The solvent is bigger. It's what you're putting the stuff into. The solute is the stuff that you're putting into the bigger thing. And you mix it together, and that is the solution. All right, so temperature is the heat of the average kinetic energy. That's pretty self-explanatory. All right, calories. So with this calories, we're not talking about like burning calories, eating calories. This calorie is a measurement. This is the amount of heat required to raise the temperature of 1 gram of H2O. Sorry, it says or, but it's supposed to say of. 1 gram of H2O by 1 degree Celsius. And we'll talk about that. So, and that gives us specific heat. So specific heat of H2O is 1 calorie, which is the calories we were just talking about, per gram per 1 degree Celsius. You need to know that. All right, cohesion and adhesion. Let's talk about that. So cohesion is pulling with hydrogen bonds. So think about a tree and think about the water going up through the roots. That's cohesion. What's pulling is cohesion. Adhesion is when stuff is sticking to the cell wall. So the water is in between the cell walls, and which is adhesion, just sticking and it's in between. And then cohesion is the pulling up. That's why it pulls up. Okay. So hydrophobic hates water. Hydrophilic loves water. So if it's hydrophobic, it's going to try to stay away from water. It doesn't want water. If it's hydrophilic, it does want water. It wants to be around water. Okay? You'll go more in depth later. So acids increase hydrogen, well, H plus concentrations, and bases reduce H plus concentrations. All right. Also, acids lower pH and bases higher pH. And when I say pH, I don't have it here, but you should have seen the pH chart, and it has 2 arrows, an arrow going up and an arrow going down. So that's what it means, the pH on that chart. Acids lower the pH and bases higher the pH. And you don't want things either way too far in either direction because it's still bad for you either way. All right, buffers. Buffers minimize changes in H plus and OH minus concentrations. So buffers are like the balancers when we're talking about pH. When we're talking about H plus and OH minus all together, but yeah, it's like the balancer. Okay? If y'all have any questions, contact me by email or the group me. I'll be there to answer. Yeah, okay, bye-bye. Good luck on your test.